7.5% of change. That is our lesson today. Make sure you have your Unit 7 note packet out and open up to lesson 7.5. You're going to want a pencil and a calculator. We are still focusing on the same standard. Minnesota says, hey, 7th graders, do the very best you can to solve real-life percent problems using equations and proportions. The main goal for today says I can solve real-life problems using the percent of change. Suppose you heard that a school was going to get 50 more students next year. You could describe this change as an increase of 50 students. Look at school A. The population right now is 1,200. Next year, they're going to get 50 more students. So they'll be at 1,250 or 1,250. Look at the population of school B. They're at 50 students this year. Next year, they're going to get 50 more. They would be at a total enrollment of 100 students. You can describe how something changed by giving the actual amount that it increased or decreased. In this case, both school populations would be increasing by 50 students. However, this doesn't always give the big picture. If the school is really large, like school A, an extra 50 students probably isn't a big deal. If the school is really small, like school B, then 50 students might be a huge deal. They might have to hire more teachers or get a portable classroom outside if the school isn't large enough. Let's look at this using percentages. So school A, if I calculate the percent of change, their enrollment is going to increase by 4.2%. Doesn't seem like that much, right? Because it's not. But look at school B. If they get 50 more students next year, which they're projected to get, then their enrollment increases by 100%. And that is huge. It's often a better idea to describe change as a percentage. This can give you a bigger overall view of the change. Like with our school populations here. If it's a high percentage, that means it changed a lot in comparison to the original amount, like school B. If it's a low percentage, that means it was a small change relative to the original amount, like school A. We often describe change as a percentage to show how an amount has changed in relation to the original amount. It helps us better understand when that change is given in the percentage form. Our goal today is to work on real-life problems using percent of change. We're going to learn how to calculate percent of change because when we're looking at how much the percent has increased or decreased, it can help us better understand real-world situations, like our school population problem here. Look at the first chunk in your notes. How do you find the percent of change? That's what we're going to talk about first. Well, there's more than one way to calculate or to find a percent of change, where you're looking at an increase or a decrease. And if you Google how to find the percent of change, chances are you're going to find a list of steps to follow. It's easy to follow the steps while you're doing an assignment without really thinking about why the steps work. So let's today make sure that we try to understand the steps so it's not just a process that we memorize and forget quickly. We're going to use calculating percent of change using decimals. So with that said, what we're going to do is we're going to start by describing the change as a fraction. We're going to compare the amount of change, fill that in, to the starting amount. How do you know if it's a percent increase or decrease? How do you know what the change is? My response to that is use your logic. If the new amount is larger, then it's a percent increase. If the new amount is smaller, then it's a percent decrease. Let's practice using this percent of change formula. This example is not in your notes, 7th graders. I just want to show you how this all works in a simplistic way. So we have, what is the percent of change from 90 to 36? I want to start by calculating my change. I'm starting, this right here is my start. I'm starting at 90, I'm going to 36. Percent of change will never be negative, so you always want to make sure that you're taking the smaller value away from the larger when you're calculating the change. So it would be 90 minus 36, which equals 54. Now, is this 54 a value of increase or decrease? Well, you're going from 90 to 36. You're starting with a larger, you're going to a smaller. So this would be a decrease. To calculate the percent of change, I'm going to take the amount of change, which was 54, and I'm going to divide it by my starting amount, which was 90. Take 54 divided by 90, you get 6/10 as a decimal. Now we want to take this decimal to a percent. So we're going to move it. What's going to go on that empty hump? A 0. So 60%, and it was a decrease. So the value from 90 to 36, the value decreases by 60%. What's the percent of change from 300,000 to 350,000? We're going to start by calculating change. Nothing you need to write down, just follow along with me. We started at 300,000. We're going to 350,000. When we calculate our change, our value should not be negative. So you always want to make sure you're taking the smaller value away from the larger. So here I would start with 350,000 minus 300,000. That's going to give me 50,000. Now, does this represent 50,000 of increase or decrease? You started at 300,000, you're going to 350. That would represent an increase. Now I'm going to take my change and I'm going to plug it into my percent formula. So my amount of change was 50,000, and I'm going to divide that by my starting amount, which was what? 300,000. When I do that, 50,000 divided by 300,000, I get this repeating decimal, 0.16666. It's going to go on, right? I need to take that to a percent, so I'm going to move it. That's going to give me 16.6666, repeating forever, never, never. I want to round to the tenths place, so I'm going to underline the digit in the tenths. Look next door, is it 5 or higher? Yes, so I'm going to add one more. That's going to give me 16.7%. So it's about a 16.7% increase in value. This is how we use the percent of change formula. It's really important to first calculate your change and then plug your values into the percent formula. You need to recognize your starting value. That's an important part. And also remember, percent of change, it's not a negative concept. So we always want to, when we're calculating our change portion, take the smaller value away from the larger. Finally, pay attention to whether it's an increase or decrease. And remember to use your logic. If you're starting with a larger value and going to a smaller, it's going to be a decrease. If you're starting with a smaller value and going to a larger, it's going to be an increase. Here we go. First example, this one is in your notes. Go ahead and find it. You have some information to fill in. On the first day this school year, the student population at RMS was 740. That is the correct number. As of today, there are 717 students attending RMS. That is the correct number. What is the percent increase or decrease in student population? What are we being asked to find here? What is the percent increase or decrease in student population at RMS? Look at what we started with. This right here is my starting value. This is where I start. 740 to 717. Is that an increase or a decrease? It's a decrease, right? So percent decrease tells me I need to use this formula. I need to know what I started with and where I went to. Those are important values. Let's go ahead and let's calculate our change. That's the numerator in my formula. Take your values. I started at 740 and I went to 717. We're going to subtract them. Take the larger first. You can use your calculator. So 740 minus 717, I get 23. What does that 23 represent? We're talking about students here, right? So it's 23 and we're looking at a decrease, 23 fewer students. Now let's calculate the percent of change. So we're going to take our amount of change, which is 23, and we're going to divide it by the starting amount. Which one of these numbers is the starting amount? Right here, 740. Go ahead and divide that out. 23 divided by 740. I get 0.03108. And remember, this I need to take to a percent. So I'm going to move it, and I'm going to need to actually here, round to the nearest tenth. So yes, I know there are more digits that are showing up on your calculator, but I only need so many. So let's move it. So that gives me 3.108%. I want to round to the nearest tenths. So I'm going to underline the digit that's in the tenths. I'm going to look next door. It's a 0, so I'm just going to ignore, and I'm going to rewrite this. It's about 3.1% what? Decrease. There's my answer. So the student enrollment decreased by about 3.1%. Make sure you have this information down in your notes, and let's try another example. So here's an experiment. We have student A's weight. Okay, is 100 pounds. If we ask student A to stand again on the scale, this time with their school supplies, the scale now shows 108 pounds. By what percent does student A's weight increase when carrying school supplies? So increase, percent increase. We need to figure out what is the percent increase of student A. So let's start by calculating the change in weight. So they started, here's my start value at 100 pounds, but then when the school supplies was added, they weighed 108 pounds. So I'm going to take 108 minus 100. That's going to give me 8. So they're 8 pounds heavier, aren't they, with the school supplies, because it's an increase. Let's calculate the percent of change. So we have our amount of change, which is 8 pounds, divided by our starting amount. What was their starting weight? 100 pounds. 8 divided by 100, well, that's going to give me 800s, and I know any value out of 100, my numerator is going to be the percent, but just taking you step by step here, I'm going to move it. What does that give me? Equals 8%. Is it an increase or decrease? Well, look what we circled. Percent increase were our key operation words there, or that phrase, percent increase. So it's an 8% increase in weight when they had their school supplies added. Percentage change. Let's look at another example. Example 3. Throughout a nice summer day, you record the temperatures in the table below to the nearest percent. What was the percent change in temperature from 2 p.m. to 8 p.m.? So we need to figure out what was the percent of change from 2 p.m. to 8 p.m. So I have some key operation words here. I'm seeing them right away. Percent of change. I know I'm going to use this formula. I'm looking from 2 p.m. to 8 p.m. So if I go over here in my table here, time is the first column, temp is the second. I'm looking at 2 p.m. and 8 p.m. So it was 87 degrees, and then it dropped down to 78 degrees. So I'm going to calculate my change first. I'm always going to take away the smaller from the larger, right? Because we're not going to get a negative value. So here I'm going to go 87 minus 78. That's going to give me 9 degrees cooler. So there is my change. Now, I want to calculate my percent of change. So I'm going to take the amount of change, which is 9, and divide it by the starting amount. What was the starting amount here? right here at 2 p.m. That's where I started. So I'm going to take 87 and put that in the denominator space. 9 divided by 87, go ahead and type that in, is going to give me 0.1034, and then there are more digits. But I need to take this to a percent, so I only need so many. I'm going to move it. I get 10.34%. I want to round to the nearest tenth. So I'm going to take the digit in the tenths, underline it, and look next door. Is that 5 or higher? No, so I'm just going to ignore. That'd be about 10.3%. Now think, was it an increase or decrease? You started at 87, you went to 78. A decrease. So the temperature decreased by 10 3/10%. Example 4 is going to be our last example for today. You go shopping at Under Armour and everything is on sale. You buy a shirt for $18.90. The same shirt last week was priced at $27. How much was your discount? What percent was your discount? So we have two pieces that we need to answer here. First of all, how much was your discount? That is our change. So we have our $18.90 and $27. Let's calculate our change in the price there. Take 27 minus $18.90. What does that equal? $8.10. Is this more money that we paid or less? Well, it's a discount, right? So it's less money. So here is our change. What percent was your discount? Let's calculate our percent of change. Our starting amount of change was $8.10. We're going to divide that by the starting amount. What was the starting amount here? The $27. So $8.10 divided by 27, what do you get? 3/10. We want to take that to a percent, so we're going to move it. What's going to go on that empty hump? A 0. So this is equal to 30%. And it's a 30% discount. And we could check that, right? Take 30% of 27, so 27 times 0.3, that's $8.10. Subtract that from 27, so 27 minus $8.10, what do you get? $18.90. Boom. Percentage change. We're going to come back to this tomorrow. So let that be enough for right now. Think about what we did today. We used this formula to calculate percentage change because instead of just giving a value amount, a percentage helps us understand a situation just a little bit more.